You know, when you look at the wing of a jet or the super sleek frame of a race car, we're just surrounded by tech that's constantly pushing the limits. But the real secret, it's not always what you can see. It's hidden away, deep in the materials themselves. Welcome to Next Gen Manufacturing. Today, we're going to pull back the curtain on the science behind these incredible materials that are literally building our future. Let's jump right in.
So here's the big question, right? It feels like it shouldn't be possible. We want airplanes that sip fuel, wind turbines with blades the size of a football field, and sports gear that gives us that extra edge. All of that stuff needs to be unbelievably strong, but also light as a feather. So, how on earth do they do it?
Well, the answer is a game-changing category of materials called composites. And the idea behind them is actually super simple, but so powerful. It's all about teamwork. You take two or more totally different materials, you combine them, and what you get is something brand new, something way better than either of them could ever be on their own.
Okay, to really get this, just think about something you see all the time, reinforced concrete. Now, concrete by itself is great if you squeeze it, but it cracks if you try to stretch it. Steel rebar? It's the exact opposite. It's fantastic when you pull on it. So by putting the steel inside the concrete, you get this amazing new material that handles both pushing and pulling. That beautiful synergy, that's the exact same principle behind every single advanced composite out there.
So, if a composite is a team, who are the players on the field? Well, it turns out that pretty much every high-performance composite you'll ever find is built from two key ingredients, and each one has a very, very specific job.
On one side, you've got the fibers. Think of these as the muscles of the whole operation. They're the ones doing the heavy lifting, providing all the strength and all the stiffness. But you know, muscles can't do much without a skeleton, right? That's where the matrix comes in. The matrix is like the body. It's usually some kind of resin that holds all those strong fibers together, keeps them safe, and makes sure the workload is shared evenly across the entire team.
And you've got a whole menu of these muscles to pick from. Glass fiber is kind of the trusty, all-around workhorse. It's affordable, and you find it in everything from boats to circuit boards. Then you have the superstar, carbon fiber. This is the high-performance champion that makes Formula One cars and stealth jets possible. And then there's the tough guy, Aramid fiber. You probably know it as Kevlar, which is just incredible at resisting impacts.
And for the body that holds it all together, there are two main families. First, you've got thermosets, like epoxy. These guys go through a chemical change and become permanently hard. The best analogy is baking a cake. Once that batter is baked, there's no going back. On the other hand, you have thermoplastics. These can be melted down and reshaped over and over again, kind of like freezing water into ice and then melting it back. And which one you choose completely changes how you can make and use a part.
So having the right ingredients is great, but that's only half the story. The real magic of composites comes from how you put them all together. The manufacturing process is basically the recipe that turns these raw fibers and gooey resins into a final, rock-solid, high-performance part.
Let's start with a classic, real hands-on method called contact molding. It's exactly what it sounds like. You literally lay down sheets of fiber into a mold, by hand. Then you pour resin over them and use little rollers to squeeze out every last air bubble. Yeah, it's a lot of work, but it's absolutely perfect for making huge, complex things like a boat hull, where you just need one side to have that perfect, glossy finish.
Now, on the complete opposite end of the spectrum, you have something slick and automated called pultrusion. Get this, continuous threads of fiber are pulled from giant spools, run through a bath of resin, and then yanked through a heated die. This die shapes the part and cures it all in one go, spitting out a finished piece that just keeps on coming. This is how you can churn out tons of things like beams and rods with incredible precision.
Okay, so now we know what they are and how they're made, but this all leads to the biggest question of all. Why on earth go through all this trouble? Why not just use a good old-fashioned piece of metal?
I mean, really, this is the multi-billion-dollar question, the one that drives this whole industry. The answer isn't just one thing, but it all starts with one single, incredibly important number.
And boom! This chart says it all. What we're looking at here is specific strength, which is just a fancy way of saying strength-to-weight ratio. The bigger the number, the more punch you get for every pound. And just look at this. Steel and aluminum, our trusty metal champs, are just left in the dust. A carbon fiber composite is in a completely different league. This is the absolute game changer. For the same amount of strength, the composite part is unbelievably lighter. But being strong and light is just the opening act. It turns out composites have these other hidden superpowers that metals just can't touch, and this opens up a whole new world of engineering possibilities.
Check this out. Almost everything in the universe expands when it gets hot and shrinks when it gets cold, right? Well, our source material points out that carbon fibers have a near-zero coefficient of thermal expansion. They basically don't change size no matter how hot or cold they get. Now, that property is absolutely essential for something like a space telescope, which has to stay perfectly in focus while it's getting baked by the sun and then frozen in shadow. You just couldn't build that with metal. It's wild.
And this all brings us to the biggest idea of all, really. Composites aren't just another material you can choose. They represent a fundamental shift in how we think about making things. It's a whole new philosophy for next-gen manufacturing.
Think about it this way. When an engineer uses steel, they look through a catalog and pick an alloy that's close enough. But with composites, you start with a blank sheet of paper. You're not just designing the part anymore. You're designing the material itself at the exact same time, tailoring it perfectly for the job it needs to do.
This process gives engineers an unbelievable amount of control. You get to pick the perfect fiber, the perfect resin, and here's the coolest part, you can arrange the fibers so they run exactly along the lines of stress. You put the strength precisely where you need it, and you don't waste a single ounce of material where you don't. You're building a perfect structure from the inside out.
And that kind of leaves us with one last big thought. This leap from just picking materials to actually designing them from scratch, that's the heart of next-gen manufacturing. It opens up this future where the only real limit is our own creativity. So the question isn't just about what composites can do for us today, but what amazing problems will we solve tomorrow when we can create the perfect material for literally any challenge we can dream up.